So here we have a differential equation that can be reduced to variable separable form. So let us begin. So we will rewrite this differential equation as dy over dx equals to alpha squared divided by x plus y whole squared. Now we cannot separate the differentials here. That's because we have x plus y, this particular term, on the right hand side. So we'll make an assumption here. Let us suppose that x plus y equals to a variable v, and then we differentiate both sides with respect to y, x. So that gives us dy over dx equals to dv over dx. Isolating dy over dx, so we have dv over dx minus 1. So we substitute this value back into our original differential equation. So this becomes now dv over dx minus 1 equals to alpha squared divided by v squared. So dv over dx is equals to 1 plus alpha squared over v squared. Further solving, we have dv over dx is equals to v squared plus alpha squared divided by v squared. Now separating the differentials, we have dx is equals to v squared divided by v squared plus alpha squared times dv. So this is a variable separable form. That means we can integrate both sides. The integration of the dx is pretty simple. So that's x. To integrate the integral on the right hand side, what we will do, we'll add alpha squared and subtract alpha squared, so that this differential can be written as, so we have v squared plus alpha squared divided by v squared plus alpha squared minus alpha squared divided by v squared plus alpha squared dv. So x will be equals to integration dv minus alpha squared being a constant. We have pulled it out. dv divided by v squared plus alpha squared. So x will be equals to v minus, so here we have alpha squared. So this is a standard formula. So we have 1 over a, so that's alpha, times tangent inverse of v over a. So a here is alpha plus the constant of integration c. Now what we do, we substitute the value of v with x plus y. So we will get x equals to, so v will become x plus y minus alpha squared over alpha. So that's simply alpha times tangent inverse of v. So v is x plus y whole divided by alpha plus the constant of integration c. So we can cancel out x from both the two sides. So we finally get y is equals to alpha times tangent inverse of x plus y over alpha. So we have minus c. So if we take c prime, then minus c prime will be simply plus c. And this is the final solution to a given differential equation.